The Great Pyramid of Giza holds a secret language in its stones. Ancient builders embedded sophisticated mathematical codes into their temples and pyramids, a hidden numerical blueprint we are only now deciphering. By the end of this exploration, you will see these iconic monuments not as silent ruins, but as active communicators speaking the universal language of mathematics. We will uncover why the sun rises in perfect alignment over Angkor Wat only on the equinox, and how a city in Mexico was laid out using Pythagorean geometry 1,000 years before the man himself was born. This journey reveals a forgotten science that connects the Earth to the cosmos through number and measure. What does our modern world overlook about the wisdom of the past? These encoded numbers form a silent language of stone. Think of it not as a secret message to be read, but as a resonant frequency to be felt, a deliberate repetition of mathematical themes that echo the order of the cosmos. This is the essence of the ancient code. It is found in the persistent recurrence of certain numbers and ratios, meticulously placed by builders who saw geometry as sacred. One of the most powerful examples is the golden ratio, a number often written as about 1.618. This is not just a number for calculation. It is a proportion that appears with stunning regularity in the natural world. You can see it in the perfect spiral of a galaxy, the unfurling curve of a fern, and the arrangement of petals on a rose. For these ancient cultures, incorporating the golden ratio into a temple was a way of grounding their creation in the very blueprint of life itself. It transformed a building from a mere shelter into a microcosm of the universe, a physical statement that the same rules governing the stars also govern human sanctuaries. This profound connection between the earthly and the divine, expressed through number and measure, is the key that unlocks our understanding of the Great Pyramid. The Great Pyramid stands as a silent testament to a forgotten science, a mountain of stone whispering mathematical truths. Its very shape encodes fundamental constants of our universe. Take its base perimeter. If you take that measurement and divide it by twice the pyramid's original height, the result is a number startlingly close to pi, the constant we use for circles. This is not a rough approximation. It is a precise geometric relationship built into a square-based structure, a profound fusion of circular and linear mathematics in one form. But the design holds another layer of genius. The ratio of the pyramid's slant height to half its base length brings us back to the golden ratio, that divine proportion of about 1.618. Having both pi and phi harmoniously integrated into a single edifice is like finding a single sentence written in two completely different, yet equally complex languages. This cannot be the result of chance or rudimentary measurement. It is the hallmark of a deliberate and advanced architectural philosophy. The builders did not just stack stones. They wove the very fabric of mathematics into the monument, aligning it with the cardinal directions with an accuracy that still defies simple explanation. How did a civilization from such a distant era possess such an integrated understanding of geometry and astronomy? The answer may lie not in one wonder, but in a pattern repeated across the globe. Far to the east, the stones of Angkor Wat speak a language of light. This sprawling Cambodian temple complex is not merely a collection of buildings. It is a colossal calendar carved from sandstone, its architecture dictated by the motions of the sun and moon. The central tower, a pinnacle reaching for the heavens, is encircled by a precise configuration of smaller towers. Their number is not arbitrary. It mirrors the cycles that govern our year, a direct representation of lunar phases and solar periods set permanently in stone. This intricate design culminates in a breathtaking annual event, On the spring and autumn equinox, an observer standing at the western gateway witnesses the sun ascending in perfect alignment directly over the central tower. This is not a happy accident. It is the result of generations of meticulous astronomical observation and staggering calendrical calculation engineered into the very foundations. The temple's vast moats and long galleries are also part of this grand design, their dimensions reflecting harmonic proportions that resonate with mathematical order. The architects of the Khmer Empire were, in essence, celestial cartographers. They did not just build a temple to look at the sky, they built a temple that was the sky, a terrestrial map of a cosmic order. This profound desire to correlate the earth with the heavens reveals a pattern of thought that spans the globe, a shared intellectual pursuit etched into monuments thousands of miles apart. This same mathematical language echoes across the ocean, written in the grand plan of a Mesoamerican metropolis. The ancient city of Teotihuacan, with its majestic pyramid of the sun and pyramid of the moon, reveals a geometric blueprint that seems to defy its own time. When researchers mapped the precise distances between these great structures, they found a pattern of perfect right-angled triangles. The sides of these triangles are not random measurements, they are whole numbers forming what we now call Pythagorean triples, like the classic 3-4-5 triangle. Here is the staggering part. This urban planning was executed in the heart of Mexico, over 1,000 years before the Greek philosopher Pythagoras was even born. The builders of Teotihuacan were not just arranging buildings, they were inscribing fundamental geometric truth into the landscape itself. This celestial connection extends from the ground to the stars. The city's main thoroughfare, known today as the Avenue of the Dead, does not merely point toward the pyramid of the moon. Its entire axis is oriented with the cyclical rising and setting of the Pleiades star cluster, a brilliant group of stars deeply significant in Mesoamerican cosmology. This creates a profound synthesis where terrestrial geometry and celestial cycles are woven together into a single sacred design. How could such similar mathematical principles appear in cultures separated by vast oceans and with no known contact? The evidence at Teotihuacan suggests a powerful possibility that this knowledge was not merely transmitted from one place to another, but was independently discovered, a universal key to understanding the world that different cultures arrived at through their own unique paths of observation and insight. The city stands as a testament to a shared human impulse to build our deepest truths into the very stones around us. These recurring mathematical patterns point to something far deeper than measurement. They are the vocabulary of a universal language known as sacred geometry. For ancient cultures, numbers and shapes were not merely practical tools. They were living symbols, each one holding profound spiritual and cosmic meaning. The circle represented unity and the infinite cosmos. The square stood for the stability of the earth and the four cardinal directions. The triangle, pointing upward, was a bridge between the earthly and the divine. This symbolic system transformed construction into an act of spiritual creation. Consider the vesica piscis, a shape formed where two circles overlap. This almond-shaped space was seen as a symbol of creation itself, the intersection of the spiritual and material worlds, a geometric womb from which all forms could emerge. Then there is the flower of life, an intricate pattern of evenly spaced, overlapping circles found etched into the stones of temples from ancient Egypt to distant Japan. This is not simple decoration. It is believed to be a blueprint of the universe, a two-dimensional map showing how all life and matter emerge from a single, sacred source. When builders incorporated these forms into a temple's floor plan or a pyramid's proportions, they were doing much more than erecting a building. They were creating a microcosm, a small-scale model of the entire ordered universe. This realization completely shifts our perspective. These sites were not passive tombs or silent temples. They were active, energetic diagrams, They were places designed for people to walk within a symbolic representation of cosmic order, to physically experience the mathematics that govern creation. To understand the full message encoded in these stones, we must learn to read this symbolic layer, to see the circle not just as a shape, but as a story of unity, and the triangle as a ladder to the stars. This practical need to measure time became the engine for mathematical discovery. A society that could predict the seasons held the key to its own survival, knowing precisely when to plant and when to harvest. This urgency transformed their temples into more than places of worship. They became colossal instruments of observation. The stones of Stonehenge stand as a perfect example, a ring of silent sentinels on the English plain. Its central axis is aligned with the heel stone, a massive outlier that captures the first light of the summer solstice sunrise. On that one day, the sun appears to rise directly from behind it, a dramatic event that marks the longest day of the year. This was not just a spectacle, it was a public announcement, a solar clock that synchronized the entire community's calendar for ceremonies and the vital work of farming. This same principle of solar alignment was engineered with breathtaking precision on the banks of the Nile. The great temple of Abu Simbel was carved directly into a mountainside. Its architects designed the entrance so that on just 2 specific days of the year, the rays of the rising sun would travel over 60 meters through the dark hall, finally illuminating the statues of 3 gods seated in the deepest sanctuary. One statue, however, was eternally left in shadow, a figure associated with the underworld. This was a masterpiece of light and shadow, a calendar in stone that celebrated the power of the pharaoh and reaffirmed the cosmic order twice annually. The mathematical planning required to achieve this effect, to angle an entire temple with such pinpoint accuracy, is staggering. The Maya took this celestial observation even further, building structures dedicated to tracking the complex dance of planets. At Chichen Itza, the observatory known as El Caracol, or the Snail, stands with its unique circular tower. Its narrow windows and strategic alignments are not randomly placed. They frame the extreme positions of Venus on the horizon, a planet the Maya watched with intense focus. Their entire ritual calendar and the timing of warfare were often tied to the appearances of Venus as both the morning and evening star. To lock these planetary cycles into a permanent building required generations of meticulous records and a sophisticated understanding of mathematics that could translate observed patterns into fixed architectural lines. These temples were the beating heart of civilization, grounding the abstract movements of the heavens into the daily rhythm of human life. They proved that mathematics was never just numbers on a page. It was the very language used to build a bridge between the earth and the sky. The precision of these ancient sites hints at a tool far more sophisticated than simple ropes and stakes. From the windswept plains of Salisbury to the remote Scottish Isles, the stones themselves seem to speak a common language of measure. In the mid-20th century, an Oxford engineer named Alexander Thom made a startling proposal after surveying hundreds of Neolithic stone circles. He found their dimensions were not random. Instead, they appeared to be based on a single, standardized unit of length, which he called the Megalithic Yard, measuring approximately 2.72 feet. This was not a rough estimate. The same unit, with astonishing consistency, appears in the diameters and perimeters of circles separated by hundreds of miles and built over many generations. The implication is profound. It suggests that the scattered communities of prehistoric Europe were not isolated tribes, but participants in a shared intellectual tradition. They possessed and used a common standard of measurement, a universal ruler for the sacred landscape. The mathematical coordination required to maintain this standard across such vast distances and centuries is staggering to contemplate. It challenges the very idea of these societies as primitive, pointing instead to a sophisticated, interconnected world with a means of communicating complex geometrical knowledge. The existence of the megalithic yard would be a powerful piece of evidence for a forgotten chapter in human history, one where a common metrology or science of measurement linked cultures we thought were separate. This leads to an even more intriguing question. What tools could they have possibly used to achieve such exacting and widespread precision without the writing systems or metal tools we would assume are necessary? The answer may lie not in a physical tool, but in a living one. The simplicity of their tools makes their achievements all the more astonishing. Ancient engineers did not have laser levels or GPS satellites. Their toolkit was elemental: rope, wood, stone, and water. Yet with these humble materials, they achieved a precision that can still confound modern surveyors. The key was a deep, practical understanding of geometry. To lay out a perfect right angle for a pyramid's corner, they used a simple knotted cord. By tying 13 knots at equal intervals along a rope, they created a loop with 12 equal segments. Staking out 3 segments in one direction, 4 in another, and stretching the remaining 5 to connect the ends, they formed a perfect right-angled triangle. This 3-4-5 triangle method is a fundamental principle of the Pythagorean theorem, applied with nothing more than a rope. For vertical truth, they relied on the plumb bob, a weighted string that always points directly to the Earth's center, ensuring their colossal walls rose straight towards the heavens. To establish a level plane across vast foundations, they used water channels, knowing that water always finds its own level, creating a perfect horizontal reference. Their astronomical alignments required even more refined instruments. The Egyptian merk was a simple forked stick with a plumb line, used to track the transit of specific stars across the night sky. By sighting a star as it crossed a predetermined meridian, a priest astronomer could determine true north with incredible accuracy, setting the orientation for an entire temple complex. The true marvel, then, is not found in the complexity of the tools, but in the profound knowledge of the people who wielded them. They possessed a working mastery of geometry, trigonometry, and arithmetic that was not locked away in scrolls but lived in their hands. This was a science that was felt, applied, and tested on a monumental scale. They could look at a simple rope and see the invisible angles of a perfect triangle. They could observe the slow drift of stars and translate that motion into the immovable alignment of a 1,000-ton stone. This practical genius forces a profound reconsideration of our intellectual history. It reveals a lineage of engineers and astronomers who, with elemental tools and an unwavering grasp of mathematical truth, encoded the order of the cosmos into the very bones of the earth. Numbers themselves were vessels of cosmic meaning. To the ancient mind, a number was never just a quantity. It was a living symbol, a key to understanding the structure of reality. The number 7 resonates across civilizations. In Mesopotamia, it was tied to the 7 celestial bodies visible to the naked eye. In Vedic traditions, it represented the 7 stages of consciousness or the 7 worlds. This sacred number was literally built into the landscape, seen in the 7 ascending tiers of a Mesopotamian ziggurat, each level a step closer to the divine, mirroring the perceived layers of heaven. This was not mere ornamentation. It was a physical prayer, an architectural mantra repeating a number that connected the earth to the cosmos. Another profound example is the number 12, a symbol of perfect order and cyclical completion. We see its power in the 12 months of the year, the 12 signs of the zodiac, and the 12 primary deities of the Greek pantheon. When a city was designed with 12 gates, it was not simply for defense. It was declaring itself a microcosm of a harmonious universe, its very foundations aligned with the celestial clockwork. This symbolic language even defines our modern measurements. The ancient Babylonians, with their advanced base 60 number system, saw 60 as a highly divisible, perfect number. Their mathematical legacy is why our hour is divided into 60 minutes, our circle into 360 degrees. Every time you check the time or use a protractor, you are using a tool shaped by ancient numerical symbolism. So when we find these numbers encoded in a temple's dimensions or a city's plan, we are uncovering a second layer of communication. The first is the practical geometry of alignment and proportion. The second is this deep, philosophical narrative written in the language of numerology. The builders were not just counting, they were weaving the very concepts of time, order, and the divine into the mortar between their stones, creating structures that were as much philosophical statements as they were physical shelters. The same sacred numbers appear across continents, separated by oceans and millennia. This pattern presents a tantalizing historical puzzle. Did these mathematical codes emerge independently in the minds of brilliant but isolated architects, or did they flow from a single, now forgotten source? The theory of independent invention argues that humanity shares a common cognitive toolkit. When different cultures turn their gaze to the same stars, measure the same land, and ponder the same cycles of life, their brightest minds may well arrive at similar geometrical truths. The golden ratio's pleasing balance, the fundamental necessity of the right angle for stable construction, the inescapable rhythms of the solar year, these are universal challenges that could naturally lead to universal solutions. It is the story of human ingenuity flowering in parallel, a testament to the shared logical structure of the human mind when confronted with the puzzles of the cosmos. Yet the precision of the parallels gives us pause. The harmonious integration of pi and phi in the Great Pyramid is not a rough approximation. It is a sophisticated geometric achievement. Finding that same divine proportion and those same Pythagorean triples at Teotihuacan, a city that flourished 1,000 years before Pythagoras walked the earth, creates a resonance that is difficult to attribute to chance alone. This has led some to propose a more controversial idea, a shared source for this advanced knowledge, perhaps a lost civilization, a precursor culture now swallowed by the sea or desert sands, once possessed this integrated science of number and sky, and its survivors scattered, seeding this wisdom across the globe. Or maybe, long before recorded history, there existed a web of cultural exchange so vast that ideas traveled between Egypt and the Americas, a forgotten network of ancient explorers and thinkers. This debate strikes at the very foundation of how we view human history. Our textbooks often present a linear, isolated progression of civilizations. But the stones of these ancient sites whisper a different, more interconnected story. They challenge the neat timelines we have constructed, suggesting a past far more complex and collaborative than we have imagined. The evidence does not force us to choose one answer definitively. Perhaps the truth is a beautiful synthesis, a blend of both independent genius and sporadic, ancient contact. Some principles were undoubtedly rediscovered by cultures solving their own problems, while other, more complex mathematical concepts could have been rare and precious cargo on long-lost trade routes. To truly grasp the magnitude of their achievement, we must move beyond the debate of origin and ask a more profound question. What was the ultimate purpose of this global project? Why go to such extraordinary lengths to encode the universe in stone? The Parthenon stands on the Acropolis not as a rigid monument, but as a living lesson in how to see. Its apparent perfection is a brilliant deception, a collection of subtle curves and calculated adjustments designed to correct for the failings of human vision. The architects Ictinos and Callicrates knew that absolute geometric straightness would appear flawed to the eye. A long, flat base would seem to sag in the middle, and perfectly parallel columns would look as if they were leaning outward. So they engineered a solution called intosses, a gentle swelling in the central shafts of the marble columns. This slight convex curve makes the columns appear straight and muscular, as if bearing the weight of the roof with dynamic strength rather than static strain. Even the platform upon which the temple rests curves upward almost imperceptibly at its center. These were not construction errors. They were preemptive corrections for an optical illusion, a fusion of mathematics and psychology carved in stone. The temple's harmony is further defined by a web of precise ratios. The relationship between its length and width, the spacing of its columns, and the proportions of its facade all resonate with the golden ratio, that universal constant of beauty. Every measurement was part of a grand calculation aimed at a single goal: to create a visual experience of perfect balance and serene order for the person standing before it. This represents a profound philosophical leap. The Greeks understood that mathematical truth and perceived truth were not the same. A building could be geometrically perfect on a drafting board, but if it looked wrong to the human eye, it had failed. Their genius lay in bending the rules of mathematics to serve the realities of human perception, crafting an ideal that was felt, not just measured. This artistic and scientific mastery invites a deeper question about all the ancient sites we have explored. If their builders went to such lengths to encode cosmic order and please the human senses, what was the ultimate purpose of this immense, global undertaking? This same sequence of numbers appears in the very architecture of life. Look closely at a pine cone, a sunflower, or the chambered nautilus. You will find a repeating pattern of spirals, and if you count them, the numbers are almost always consecutive figures from the Fibonacci sequence. This is the series where each number is the sum of the two before it, beginning with 0 and 1. So it runs 0, 1, 1, 2, 3, 5, 8, 13, and continues infinitely. The fascinating part is how this simple rule for generating numbers governs the growth of so many living things, creating a spiral that allows for maximum packing of seeds or leaves without overcrowding. This growth pattern produces a shape that is inherently efficient and visually harmonious, and it is mathematically linked to the golden ratio. As the sequence progresses, the ratio between each number and its predecessor gets closer and closer to that divine proportion of about 1.618. The spiral of a galaxy and the curve of a seashell follow the same mathematical law. Now, consider the ancient builders who were master observers of their natural world. They may not have written out the Fibonacci sequence in a textbook, but they understood the beauty and balance it created in a sunflower or a branching tree. Is it so difficult to believe that they would seek to replicate that same organic perfection in their temples? This could explain the profound sense of rightness we feel when standing before certain ancient structures. Their proportions are not arbitrary. They echo the growth patterns of the living world, creating a visual rhythm that feels both familiar and majestic. The Parthenon's facade, for instance, is often analyzed for its use of golden rectangles, proportions that are generated by the Fibonacci sequence. While scholars debate whether the Greeks explicitly used the sequence, the harmonious proportions are undeniably present, resonating with the same mathematical order found in a pine cone. This suggests that the most advanced ancient mathematics was not an abstract game for priests and kings. It was a practical science of observation, a conscious effort to translate the deep, underlying patterns of nature into stone. They were not just building shelters, they were cultivating a forest of columns that grew with the same logic as the trees, and crafting stone petals that unfolded with the same mathematical grace as a flower. This slow wobble in the Earth's axis, the precession of the equinoxes, completes one full cycle every 26,000 years. It is a timescale so vast it defies simple human comprehension, a cosmic clock whose hands move with glacial slowness. Yet, some researchers suggest this profound astronomical knowledge was not only understood by ancient cultures, but deliberately embedded into their greatest works. The theory proposes that the three pyramids of Giza are not a random grouping. Their arrangement on the ground, according to this view, is a precise terrestrial map of the three stars of Orion's belt, but not as we see them today. The layout is argued to mirror the celestial pattern as it would have appeared in the sky around 10,500 years before the Common Era. This date is not arbitrary. It aligns with a specific point in that grand 26,000-year precessional cycle, a time when Orion was at its lowest point in the sky, a symbolic rebirth or beginning. The Great Sphinx, gazing eternally eastward, is part of this same celestial blueprint. Its leonine form is said to correspond with the constellation Leo, which would have risen directly ahead of it on the spring equinox during that very same distant epoch. If these alignments are intentional, the implication is staggering. It means the ancients were not merely building monuments to mark the present sky. They were constructing a permanent record of the sky's slow dance across millennia, a stone calendar tracking time on a scale we can barely grasp. This idea challenges the foundations of our historical timeline, suggesting a level of astronomical sophistication that pushes the origins of this science back thousands of years earlier than accepted. It invites us to wonder if these structures were designed as a message in stone, a warning or a gift from a lost age, intended to speak across the ages to a future civilization that could finally read the stars as they did. Centuries after the last pyramid was sealed, the same yearning to unlock an ancient secret found its voice in a quiet man working alone in the Florida night. Edward Leedskalnin, a Latvian immigrant, single-handedly built what is now known as Coral Castle, a sprawling complex of massive stone sculptures and walls. With no formal engineering training and using only hand tools, he quarried, transported, and precisely positioned over 1,000 tons of oolitic limestone. Some of these blocks weigh more than a fully grown male elephant, yet he manipulated them without the aid of cranes or modern machinery. When asked how he accomplished such a feat, Leedskalnin would only offer a cryptic smile, stating that he had simply rediscovered the building secrets of the ancient Egyptians. He spoke of understanding the laws of weight and leverage, and he hinted at a lost knowledge concerning magnetism and the Earth's energy fields, principles he believed could neutralize gravity itself. Mainstream science offers a more grounded explanation, pointing to his clever use of block and tackle systems, leverage, and a profound, self-taught understanding of physics. He likely used simple tools like chain hoists, tripods, and winches to move the immense stones inch by painstaking inch. Yet, the sheer scale of his solitary achievement, combined with his mysterious claims, leaves a lingering question mark. Coral Castle stands as a modern monument to the same enduring mystery that surrounds the pyramids. It reminds us that our explanations for these ancient wonders, while logical, are still incomplete. The site is a powerful symbol, a bridge between the enigmatic past and our persistent modern quest for answers. It proves that the allure of a lost science, a key to forgotten powers, continues to captivate and drive us to look beyond conventional understanding, searching for the hidden codes that might still be waiting to be read. High in the Andes, the stones of the Inca seem to defy gravity and time. At the fortress of Sacsayhuaman, colossal blocks, some weighing over 100 tons, are assembled into zigzagging walls that ripple across the landscape. The sheer scale is overwhelming, but the true genius lies in the microscopic gaps, or rather, the lack of them. Each polygonal stone, with its unique, irregular shape, is fitted against its neighbors with such astonishing precision that not even the thinnest blade can slip between them. This was accomplished entirely without mortar. The construction method was a masterpiece of practical geometry. Artisans likely used smaller, handheld stones as three-dimensional templates. They would repeatedly test the fit of these master stones against the evolving surfaces of the massive blocks, slowly carving and abrading the granite until the contact was flawless. This was not about creating simple, standardized bricks. It was an exercise in advanced spatial reasoning, solving a gigantic, three-dimensional puzzle where every piece was custom-shaped to lock perfectly with every piece around it. The result is architecture that behaves like a living entity. When the earth trembles during the frequent Andean earthquakes, a mortared wall would crack and crumble. But these interlocking stones have a built-in resilience. They can shift, settle, and even dance during a seismic event, only to settle back into a stable, unified structure once the shaking stops. This is a different kind of mathematical code altogether. It is not written in the abstract language of pi and phi, but in the physical grammar of topology and structural engineering. The Inca code was one of dynamic stability, a profound understanding that true strength lies not in rigid uniformity, but in a complex, custom-fit harmony. This practical mastery challenges our very definition of advancement, proving that sophistication can be found not only in celestial alignment, but in the perfect, unbreakable fit of one stone against another. The ceiling of the Dendera temple offers a breathtaking vision of the ancient sky. Etched into its stone is a detailed zodiac, a celestial map that captures the positions of constellations as the Egyptians perceived them. Yet this star chart is far more than decoration. The entire temple complex, from its grand axis to the layout of its inner chambers, is believed to be a physical echo of this cosmic diagram. Walking through its halls was meant to be a journey through the heavens themselves, a deliberate architectural ritual that grounded the cosmos on Earth. This concept of the temple as a cosmogram, a miniature model of the universe, finds a powerful parallel thousands of miles away. In the tradition of Hindu temple architecture, every structure begins with a sacred diagram known as the Vastu Purusha Mandala. This intricate geometric grid is more than a floor plan. It is a symbolic representation of the cosmic being, with each square and intersection corresponding to a specific deity or cosmic force. The temple is constructed upon this mandala, its walls and towers rising in perfect alignment with the cardinal directions, designed to channel and harmonize the energies of the universe. This was the ultimate purpose of the mathematical codes we find repeated across the globe. They were not merely tools for achieving structural stability or astronomical alignment, though they accomplished that with stunning precision. Their deeper function was to create a sacred space, a point of perfect resonance where the human and the divine could meet. The mathematics provided the invisible framework that made a building spiritually alive, transforming inert stone into a vibrating link between our world and the cosmic order. This profound unifying theme reveals that for our ancestors, architecture was the highest form of prayer, a silent, enduring conversation with the stars built from the universal language of number and form. The stones of these ancient temples could also sing. Beyond the silent language of geometry and astronomy lies a hidden dimension of sound, an auditory code woven into the very fabric of structures like the hypogeum of Malta. This underground labyrinth, carved from solid rock over 5,000 years ago, contains chambers that are not just rooms but finely tuned resonators. When a voice chants at a specific, low frequency within these spaces, the sound does not simply echo. It amplifies and fills the entire chamber, vibrating through the stone and the very bones of the listener. This is not a random effect. It is the result of a precise understanding of sound waves and the physics of resonance, where the dimensions of the room are calculated to reinforce a particular note. Researchers suggest this powerful sonic environment could have been used in ceremonial practices, its vibrations potentially facilitating shifts in awareness or states of deep meditation. The builders were clearly manipulating sound with intention, using mathematics to create an experience that was felt as much as it was heard. This acoustic mastery echoes across the Atlantic. At the Mayan pyramid of Kukulkan at Chichen Itza, a simple handclap at the base of the grand staircase produces a startlingly unnatural echo. Instead of a dull thud, the sound that returns is a sharp, chirping cascade, a perfect imitation of the sacred Quetzal bird, a creature deeply woven into Mayan cosmology as a messenger between the earth and the sky. To achieve this specific sonic effect, the architects had to calculate the exact spacing and angle of each step to break the sound wave into a rapid series of reflections. This is auditory mathematics in its purest form, a deliberate encoding of a cultural symbol into the very soundscape of the temple. These examples reveal that ancient technological prowess was not limited to the visual. They were designing multi-sensory environments where the harmonic properties of sound were as integral to the design as the proportions of the walls. The goal was to create a total psychological and spiritual experience, using resonant frequencies to stir emotion, deepen ritual, and connect the physical world with the realm of the symbolic. This sonic layer adds a profound new depth to the mystery, suggesting that to truly hear the message of the ancients, we must learn to listen to the silence they left behind. The seafloor yielded a secret more complex than any treasure, recovered from an ancient shipwreck near the Greek island of Antikythera. A corroded lump of bronze and wood sat for decades before its true nature was understood. This was the Antikythera Mechanism, a device so intricate it has been called the world's first analog computer. Crafted around the 2nd century before the Common Era, it was a masterpiece of miniature engineering, a complex clockwork of interlocking bronze gears housed in a wooden case. Its dials and pointers, driven by a hand crank, did not tell the time of day. They charted the time of the cosmos, predicting the movements of the sun and moon, forecasting eclipses, and even tracking the 4-year cycle of the Olympic Games. To turn a simple handle and see the celestial dance unfold on a series of dials was to possess a portable universe, a mechanical model of the heavens. The sophistication of its gear trains, including a differential gear, was a level of mechanical engineering that would not be seen again until the clocks of the 14th century in Europe. This was not a technology that appeared from nowhere. It stands as tangible, physical proof that the ancient Greek world possessed an extraordinarily advanced and integrated understanding of astronomy, mathematics, and precision engineering. The Antikythera Mechanism forces a dramatic recalibration of our entire view of ancient technological capability. It is a surviving relic of what was likely a rich tradition of complex devices, most of which, constructed from wood or other perishable materials, have simply vanished from the historical record. This single, miraculous survivor elevates our estimation of ancient scientific achievement, suggesting a landscape of knowledge where the theoretical brilliance of Archimedes and the mathematics of the Great Library of Alexandria were translated into working machines of stunning complexity. The challenge of squaring the circle was far more than a mathematical puzzle. For ancient philosophers, it represented the ultimate act of cosmic harmony, a geometric metaphor for uniting the boundless heavens with the ordered world of humankind. The circle, with no beginning and no end, symbolized the infinite, the spiritual realm, and the cycles of the cosmos. The square, with its 4 equal sides, represented the solid, material earth, the 4 cardinal directions, and the foundation of stable existence. To create a square with the exact same area as a given circle using only the simple tools of a compass and straightedge was an attempt to capture the divine within the mundane, to give measurable form to the immeasurable. We now know this is a mathematical impossibility, as pi is a transcendental number, yet this very impossibility is what made the pursuit so profoundly meaningful. It was a spiritual exercise, a meditation on the relationship between the perfect, ideal world of forms and our own imperfect physical reality. This powerful symbol was etched into sacred art across the globe. In the intricate sand paintings of Tibetan Buddhism, the mandala often features a square palace representing the ordered world, enclosed within a concentric circular border, symbolizing the universe in its entirety. To enter the mandala through meditation is to symbolically square the circle, to bring the individual self into perfect alignment with the cosmic whole. This same symbolic intention may be physically embodied in the Great Pyramid. Its massive square base is firmly planted on the earth, while its original height, when used as a radius, generates a circle with a circumference nearly matching the pyramid's perimeter. This is not a literal solution to the geometric problem, but a breathtaking architectural expression of the same ideal. The builders were not just solving equations, they were building a philosophical statement, a mountain of stone declaring that the earth and the sky are fundamentally connected through number and measure. This reveals a core driver of ancient mathematics that is often forgotten today. The pursuit of knowledge was not merely for practical application, but for spiritual and philosophical understanding. They used geometry as a language to ask the biggest questions about the nature of reality, seeking to represent the fundamental relationships of the universe in a form that could be seen, touched, and walked within. Our modern world runs on a mathematical system gifted to us by the sands of ancient Mesopotamia. The Babylonians, using nothing more than a stylus and wet clay, developed a numerical framework of such elegance and power that it still dictates how we measure our hours and chart our skies. Their base 60 or sexagesimal system was a stroke of genius. Unlike our base 10 system, which relies on factors of 2 and 5, 60 is divisible by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This made complex calculations, especially with fractions, remarkably smooth and efficient. This is why, thousands of years later, we still have 60 minutes in an hour and 360 degrees in a circle. Their innovations did not stop there. They crafted advanced algebraic methods to solve quadratic equations and tracked the motions of planets with a precision that would not be surpassed for over a millennium. Their calculated value for the solar year was within minutes of our modern measurement, a feat of observation carved into durable cuneiform tablets. This was not abstract play, it was a rigorous, applied science, and it formed the indispensable bedrock upon which later Greek and Hellenistic mathematicians would build their own philosophies. When we marvel at the celestial precision of the Parthenon or the Great Pyramid, we are likely witnessing the application of a knowledge base that had been carefully compiled and refined in Babylonian scholarly centers for centuries. This perspective fundamentally shifts the narrative. The mathematical codes hidden in temples across the globe begin to look less like a series of isolated miracles and more like chapters in a single, sprawling, intercontinental story. It was a cumulative process of discovery where each culture absorbed, refined, and reinterpreted a shared body of knowledge, expressing it through the unique lens of their own beliefs and environment. By acknowledging the profound Babylonian contribution, we see the true architecture of intellectual history, not as isolated towers of genius, but as a great, interconnected city of ideas, built one clay tablet at a time. Prime numbers stand apart in the mathematical universe, indivisible and unbreakable, their unique nature echoing the ancient search for permanence. These numbers, which can only be divided by one and themselves, were likely seen as more than just counting tools. They were symbols of elemental purity, the fundamental atoms of arithmetic. This has led some researchers to a fascinating speculation that prime numbers were deliberately woven into the very fabric of sacred sites to create patterns that were as symbolically strong as they were mathematically unique. Imagine the layout of a stone circle. If the number of major standing stones is a prime, like 7, 11, or 17, it creates a formation that cannot be divided into equal, smaller groups. This indivisibility might have been perceived as a source of ritual strength, a way to make the sacred space itself eternally whole and resistant to being broken down. It moves the mathematical code from the visible realm of shapes and ratios into the invisible, abstract world of pure number theory. While proving intentional use is challenging, the possibility is profound. It suggests the architects were not just master geometers but also number philosophers, operating with a concept of numerical sacredness that predates our modern understanding of primes by millennia. This expands the mystery from spatial harmony to numerical encryption, adding a layer of code that is felt not in the curve of a wall, but in the irreducible count of its parts. The mandala transforms meditation into architecture. In the quiet of a monastery, a master begins with a single point, the bindu, representing the unmanifest source of all creation. From this center, a perfect circle is drawn, then enclosed within a protective square with 4 elaborate gates. This foundational act is not art, but a precise geometric ritual, a coded diagram of the cosmos filled with symbolic patterns and deities. The entire process of constructing a sand mandala is a profound meditation on the nature of reality, a temporary universe built grain by grain only to be swept away in a powerful lesson on impermanence. This same sacred geometry was then scaled to an unimaginable degree, becoming the literal foundation for one of the world's greatest monuments. The Temple of Borobudur in Indonesia is not merely a building inspired by a mandala. It is a mandala, a colossal, walkable one. Its entire structure, from its massive square base to its concentric circular terraces crowned by a central stupa, is a direct physical translation of the spiritual diagram. A pilgrim does not simply walk through Borobudur, they enact a ritual journey. The path leads from the outer world of desire, represented by the heavily sculpted lower levels, inward and upward through galleries depicting the life of the Buddha, and finally to the open, circular platforms at the summit. Here, the geometric progression culminates in a state of formlessness and enlightenment, the center of the cosmic map. This is the mathematical code in its purest spiritual form. The ratios and proportions are not used for structural integrity alone, but as a direct script for inner transformation. Every step the pilgrim takes is a movement through a pre-calculated sacred space, designed to mirror the journey of the soul from the periphery of illusion to the silent, central core of reality. The stones themselves become a guide, using the universal language of geometry to map the path to awakening. Buried in the jungles of Mexico, the colossal stone heads of the Olmec civilization stare out with an enigmatic silence. These massive sculptures, carved from single blocks of basalt, are not merely portraits of powerful rulers. They are a different kind of mathematical code, one etched not in celestial alignments but in the human face itself. Researchers examining these heads have noticed something extraordinary. Despite their unique individual expressions, they all seem to follow a hidden rulebook of proportions. The distance from the hairline to the brow, the space between the eyes, the ratio of the nose to the mouth, these measurements are not random. They appear to be governed by a consistent, complex system of ratios, a formal canon that dictated ideal form. This discovery is monumental. It means that over 3,000 years ago, long before the flourish of the Maya or the grandeur of Teotihuacan, the Olmec were not just artists, they were geometers of the human form. They had developed a sophisticated mathematical language to standardize their most sacred art, creating a visual harmony that was both beautiful and systematically precise. This artistic canon was likely the foundation for everything they built, a proportional system that would be studied, refined, and passed down through the centuries. The Olmec heads, therefore, are more than mysterious artifacts. They are the missing link, the earliest evidence of a formalized mathematical principle that would come to define Mesoamerican architecture and art for millennia. They show us that the drive to impose numerical order on the world is not a late development in human culture, but a fundamental impulse appearing with the very dawn of civilization itself. The silent stones finally have a voice, and it speaks in a stream of laser light. Modern archaeologists are no longer limited to measuring tapes and theodolites. They now wield tools like LiDAR, which fires millions of laser pulses at a site from an aircraft. These pulses bounce back, creating a point cloud of data so precise it can build a digital twin of an entire temple complex, accurate down to the millimeter. This is not a simple photograph. It is a perfect three-dimensional replica that can be rotated, measured, and analyzed from any angle in a laboratory halfway around the world. With this model, a researcher can test the alignment of a specific corridor with a star that has not risen in that position for 4,000 years, confirming an astronomical theory without ever setting foot in the desert. They can calculate the volume of a hidden chamber, or check the flatness of a pyramid's casing stones with a level of detail that was physically impossible just a generation ago. This digital revolution extends to sound as well. Sophisticated acoustic modeling can simulate how a specific chant would have reverberated through the hypogeum of Malta, allowing us to hear, in a virtual space, the resonant frequencies the builders so carefully engineered. From the sky, satellite imagery and geomagnetic surveys act like X-ray vision, revealing the ghostly outlines of buried foundations, ancient roadways, and entire plazas that have been swallowed by the earth. These grand patterns, invisible from the ground, often hold the key to understanding the city's overall geometric plan. We are, for the first time, able to see the forest instead of just a few individual trees. This technological leap is like finally being handed the original architectural blueprints for these ancient wonders. We are no longer just guessing at their intentions. We are measuring their mathematical signatures with a clarity that honors their original precision, uncovering a hidden layer of intelligence that has been waiting in plain sight for millennia. Yet a vital counterpoint emerges from the halls of academic skepticism. Many archaeologists urge a cautious interpretation of these mathematical wonders. They point to a phenomenon often called number juggling, where with a vast set of measurements, one can selectively choose which numbers to compare until a desired, impressive ratio like pi or the golden ratio appears. From this viewpoint, the appearance of these complex constants is often coincidental, a happy accident of interpreting ancient designs with modern mathematical lenses. These scholars argue that ancient builders primarily relied on simple, robust ratios for practical construction, like the dependable 3-4-5 triangle to create perfect right angles. A symbolic meaning for a shape or a number, they clarify, is not the same as a deliberate, precise mathematical code. This perspective serves as a crucial reminder of the gap between our contemporary fascination with specific irrational numbers and the practical, hands-on geometry of the past. It asks us to consider whether we are discovering their intentions or simply imposing our own. This critical lens does not seek to diminish the brilliance of ancient engineers, but to ground our awe in rigorous inquiry. It highlights the delicate task of the historian, who must weigh compelling patterns against the very real possibility of coincidence, always acknowledging the ultimate limits of our understanding when reading a language of stone that has no written dictionary. This balancing act between wonder and skepticism is itself a part of the mystery, pushing us to look beyond simple answers for a deeper, more nuanced truth. These silent monuments form a global chorus, all singing the same mathematical hymn. Our journey across these ancient landscapes reveals a world far more intellectually vibrant and interconnected than our history books often portray. From the pi encoded in the Great Pyramid to the Pythagorean triples of Teotihuacan, from the celestial calendars of Angkor Wat to the sonic resonance of the Maltese hypogeum, we find a consistent and powerful thread. Our ancestors wielded mathematics not as a dry academic exercise, but as a sacred language. It was their chosen tool to build a bridge between the earthly and the divine, to map the grand movements of the cosmos, and to create enduring monuments to their profound understanding of universal order. The question of whether this knowledge was independently discovered by brilliant, isolated cultures or hints at a lost chapter in our collective history remains one of archaeology's most compelling puzzles. Yet regardless of its origin, the evidence itself challenges us to dramatically expand our view of the human past. These numerical codes are not mere historical curiosities. They are a powerful testament to a universal human drive, a deep-seated need to find order, meaning, and beauty in the universe through the timeless power of numbers. The stones have spoken across the millennia, their message etched in geometry and aligned with the stars. It is now our responsibility to continue listening, to keep questioning the stories we think we know, and to carry forward this spirit of exploration into the mysteries that still await.